According to a new study that investigates an old notion that has recently made a reappearance, dark matter may be made up out of old black holes. Observations made over the course of the following year by NASA's freshly launched James Webb Space Telescope may suggest that multiple black holes originated during the universe's creation. These findings might potentially clarify how dark matter affects gravity. Weakly interacting massive particles, which are large, slow-moving theoretical particles that exert a gravitational pull on ordinary matter, are used in several particle physics theories to explain the existence of dark matter. But according to Benjamin Lehman, a physicist and PhD candidate at the University of Santa Cruz who researches dark matter and particle physics and was not involved in the work, that hypothesis has been in growing tension with recent experimental results. The community of particle physicists has therefore been eager to investigate more potential sources of dark matter, including revisiting earlier theories in new models. The largest telescope worth $1 billion has been launched and is currently unfolding in space. Scientists learned that this initiative would enable the examination of one of Stephen Hawking's most contentious hypotheses about black holes after it had already begun its journey across space. The scientists are interested in learning more about this notion and how it will be disproved using the James Webb Space Telescope. Welcome to Cosmos Lab, your one-stop shop for space news. Discover the theory and how the biggest space telescope will resolve the enigma in today's video. In many of our earlier videos, we discussed the James Webb Space Telescope. According to NASA, the solar screen for the James Webb Space Observatory, which is the size of a tennis court, has now fully deployed, signifying a significant advancement in the mission of the Space Telescope to study every single stage of cosmic history. The kite-shaped structure, which is 70 feet or 21 meters long and serves as a parasol, keeps Webb's equipment in the shadow so that they can detect minute infrared signals from the farthest regions of the universe. Each layer came off one by one over the course of 2 days. When they cooperate, they offer an SPF sun protection factor of around 1 million. The 5-membrane solar shield's deployment is a victory for the engineering teams at Northrop Grumman and NASA, the US Space Agency. The observatory is now being unpacked by the engineering teams from its folded launch configuration to the opening setup. According to a recent study, one of Stephen Hawking's most divisive theories may soon be put to the test. Black holes that emerged in the initial fraction of a second after the Big Bang could be the source of dark matter, according to a notion that was first put forth in the 1970s. Hawking proposed in the 1970s that black holes created in the early Big Bang might make up dark matter, the invisible substance that accounts for the majority of the universe's mass. Now a theory has been developed by 3 astronomers that explain both the development of the largest black holes in the universe and the existence of dark matter. Black holes have been studied and seen, and the world saw the first black hole photo in 2019, despite the fact that the human race has never been able to understand the existence of black matter. The European Space Agency, University of Miami, and Yale University are leading a new investigation that is based on Stephen Hawking and Bernard Carr's idea about the origin of black holes after the Big Bang. In a statement, Yale University astrophysicist and study coordinator Priyamvada Natarajan said, "What I find personally super exciting about this idea is how it elegantly unifies and resolves the 2 challenging problems that I work on, that of probing the nature of dark matter and that of the formulation and growth of black holes." LISA and the James Webb Space Telescope will disclose new information about black holes. In their most recent study, Natarajan, Gunther Hassinger of the European Space Agency and Nico Capelluti of the University of Miami investigated the hypothesis of primordial black holes to see how it can explain dark matter and possibly address other cosmological problems. By looking for the first stars, galaxies and supermassive black holes in the cosmos, they discovered that primordial black holes may have had a significant impact on the creation of the universe. SMBHs. They said that their findings suggest that stars, galaxies, and supermassive black holes emerge and grow in the past cosmologically very swiftly, possibly too quickly to be explained by the mechanisms seen in the universe today. Although this is still just a model, experts think that it may be tested shortly. According to them, the James Webb Space Telescope was created primarily to provide answers regarding the creation of stars and galaxies. The Laser Interferometer Space Antenna, LISA in particular, is poised to reveal a great deal more about black holes, even primordial ones if they exist, in the coming generation of gravitational wave detectors. Together, the 2 observatories, according to astronomers, should provide scientists with enough data to piece together the history of the first stars and perhaps even the beginnings of dark matter. Stephen Hawking postulated in the early 1970s that the earliest black holes may have formed in concentrated pockets in the extremely hot and compact early cosmos. A crucial feature that the large-scale structure of the universe is the product of microscopic perturbation moments after the Big Bang is what allows for the emergence of black holes at the beginning of time, which are known as primordial black holes. According to the hypothesis, pockets of these fluctuations would reach a critical density and be ready to collapse into black holes, but the extreme heat surrounding them would prevent this from happening right away. According to Gunther Hassinger, the director of science at the European Space Agency and an expert in X-ray astronomy, the universe was so hot that particles were zipping around like crazy, preventing them from collapsing into black holes until it had expanded and cooled sufficiently. Hassinger is also the author of a new study that will be published in the Astrophysical Journal. According to Hassinger, this collapse would only occur if quarks, which are elementary particles, can combine to form protons, which would happen when the universe is just a fraction of a second old. According to Nico Cappelluti, an astronomer at the University of Miami who conducted the study, the team wanted to determine whether the universe as we know it today could have been created using this new cosmology of primordial black holes. Their simulation revealed that a universe with the dark matter created by primordial black holes could resemble our own quite closely. Dark matter and primordial black holes don't have to coexist, claims Lehman. Primordial black holes are one kind of dark matter that could exist. He claims that the sheer amount of scientific conundrums that might be explained with this one model is astounding, and the study's methodology was thorough. With the help of the team's model, stars should have formed after only 50 million years as opposed to the 300 million years anticipated by the mainstream model. According to Cappelluti, a detailed examination of the far-off and distant reaches of the universe might help scientists find a solution to this discrepancy. The James Webb Space Telescope, built to study signals from more than 13.5 billion years ago, might provide a link between Hawking's long-held theory and dark matter. Researchers didn't have a genuine sense of scale when Hawking put up the idea of primordial black holes, Hassinger claims. Scientists searched for the gamma rays produced by tiny black holes in the years that followed because they believed that black holes they created would be very small. The concept was abandoned by the majority of academics for decades when they couldn't find them. It wasn't until much later that researchers understood the existence of primordial black holes in a variety of sizes, including much heavier ones. According to Hassinger, the first gravitational wave detectors revealed heavier black holes than astronomers anticipated, which furthered the theory of primordial black holes. According to Cappelluti, there remains a large gap in our understanding of the early cosmos, even with the greatest telescopes available today. The cosmos is around 14 billion years old, yet astronomers can only view the last 13 billion years of its existence. He claims that the missing billion years are replete with unanswered mysteries, such as how we came to have black holes that are billions of times more enormous than the Sun. With the current understanding of physics, it is difficult to explain how these supermassive black holes form. In most cases, scientists just come up with a theory and attempt to shoot it down, according to Hassinger. A theory gets more solid the more times attempts to refute it fail. The idea endures if it cannot be refuted, at least until the subsequent wave of research and experimentation. Future findings could mark a significant turning point in the quest for primordial black holes, regardless of whether the team's idea is disproved. Hassinger warns that we would be in trouble if researchers look at the most in-depth Webb findings and don't see a hint of a shift for the mainstream model. This sums up today's video. Let us know your opinion in the comments section below. Thanks for watching.